This week is basically a masterclass in the system did exactly what we built it to do. Cloudflare automated something that touches routing, and a bug turned into real BGP withdrawals for customer prefixes. Clerk got taken out by a query plan flip. Nothing crashed, the database was up. It was just slow enough to light everything on fire. And AWS is in the middle of a new era where internal tools can take bigger actions faster. And the whole story comes back to permissions and guardrails. If you run production, this is your week. Hey, I'm Brian from Tellers Tech, and this is Ship It Weekly, where we cover outages, releases, and incident write-ups, then translate them into what it actually means for your systems. If you like the show, follow or subscribe wherever you are listening. And if you've got an on-call buddy, send them this episode. That share does more than you'd expect. Also, quick plug, full show notes live on shipitweekly.fm, and the curated weekly brief is on oncallbrief.com. All right, quick overview so you know where we're going today. First, Cloudflare's BYOIP outage, where a cleanup job ended up withdrawing customer prefixes. It's a really clean example of how background automation can become production blast radius if it touches routing or reachability. Second, Clerk's outage from a Postgres auto-analyze triggering a query plan flip. The database was up, but performance tanked, and the system started shedding load. It's a great case study in why degraded is sometimes harder than down. Third, the AWS Kiro story, and the follow-up response from AWS. Regardless of the headline, the useful lesson is permissions. If a tool can take actions, it's part of your control plane, and it needs real boundaries and approvals. After that, I'll do a quick platform note on the EKS node monitoring agent going open source, then a tight lightning round. Then we'll close with a human section on why SRE is basically allergic to ticket queues. All right, story one. So Cloudflare had an outage tied to BYOIP, bring your own IP. If you are not familiar, the idea is simple. Customers want to use their own IP ranges at the edge. So traffic still comes from the IP space they own, even though Cloudflare is doing the heavy lifting. The scary part is what makes it powerful. It's real routing, BGP announcements, prefixes, internet reachability. Cloudflare's postmortem is one of those that's uncomfortable because it's relatable. A cleanup subtask was designed to remove BYOIP prefixes that should be removed. Basically, automate a manual workflow so support and ops don't have to do it by hand. But the cleanup job had a bug. The query it ran against, their own internal API, returned more prefixes than it should have. And the system started withdrawing prefixes that were still in use. At peak, they say around 1,100 prefixes were unintentionally withdrawn for a window of time. And then the incident as a whole took hours to fully unwind, because even after you stop the bleeding, you are stuck restoring state across a big distributed system. This is the part I want to linger on, because it's the part that teams tend to underestimate. When you withdraw routes, a rollback isn't just flipping a flag. You are waiting on propagation. You are dealing with caches. You are dealing with partial state. You are dealing with bindings and dependencies that get removed or drift. Cloudflare even published customer guidance during the incident that some customers could self-remediate by going into the dashboard and re-advertising their prefixes. That right there is the difference between this is bad and this is catastrophic. If your customers can do something to recover without waiting for you, you just bought yourself time. So here's the ops lesson. If you have automation that can withdraw routes, revoke advertisements, delete edge bindings, remove cert associations, change DNS at scale, or anything in that reachability control plane bucket, treat it like production deployment tooling, not like a cron job. This is the kind of automation that needs friction on purpose. It needs a safety check that says, if this job is about to touch more than n prefixes, stop. It needs canary behavior. It needs a dry run mode that produces a diff humans can look at. It needs a circuit breaker that triggers on anomaly, not on service down. Because the failure mode here is always the same. One helper job, one bug, one correlated blast radius. And nobody sleeps. Practical Monday take. Ask, what systems do we have where a background job can make reachability go away? That could be BGP, but it could also be DNS automation, certificate rotation automation, firewall rule cleanup, CDN rule cleanup, or even a Terraform pipeline with the ability to destroy and recreate shared infrastructure. Then ask one more question. If that job goes sideways, what's the fastest human-safe rollback? And does it require tribal knowledge? If the answer is we'd figure it out, congrats, you just found your next incident. Alright, story 2 is one of my favorite kind of postmortems, even though it's painful. Clerk had a system outage, and the root cause was an inefficient query plan caused by Postgres auto-analyze. So nothing exotic, no kernel panic, no region failure, no someone deleted prod. Just Postgres doing normal Postgres things. Here's the chain. Auto-analyze runs. Statistics get updated. That causes a query plan flip. Same query, different plan. That plan is dramatically worse, which drags database performance down, which backs up request handlers, which turns into queuing. And then almost all traffic starts getting 429'd without being handled. They call out that over 95% of traffic was returning 429 because the system was basically shedding load while it was drowning. The fix was pretty direct. Manually rerun analyze for the table involved, which changed the stats and brought the query plan back to the good version. What's interesting is the detail they share about why the planner got it wrong. It had to estimate how many rows would match a condition, and it used a statistic that depends on sampling. Their data had a column where almost everything was null, and because the sample was small, the sample ended up being basically all nulls. So the planner overconfidently assumed 100% nulls. The query planner then expected a certain part of the query to return basically 0 rows. But in reality, it returned something like 17,000 rows. So the plan it picked was good for 0 rows, and terrible for 17,000. That mismatch is the kind of thing that doesn't show up in unit tests. It shows up on a Thursday morning when auto-analyze decides it's time. So why does this matter for platform and SRE folks? Because a lot of teams still think in binary failure states. Database up or down, service up or down. But a huge chunk of production incidents live in the gray zone. Database is up, but slow. The service is up, but queuing. Your health checks pass, but users are screaming. They even point out that their automatic failover didn't trigger because Postgres was online, just degraded. So it didn't match the failover now conditions. And this is where the playbook needs to evolve. If your failover only triggers on dead, you're going to get smoked by limping. Clerk's remediation is worth stealing. They talk about adding alerting specifically for query plan flips because it's sudden and severe. They also talk about a mitigation that offloaded session token generation outside their core session API to reduce backend load and help people stay logged in even while other parts of the system were unhealthy. That's a classic reliability move. Protect the critical path even if the full feature set is degraded. And they're also honest about communication. They say their updates were too infrequent, their initial status severity didn't match impact, and their first update was too slow. Every team thinks they're good at comms until they're in a real outage. So Monday take. If you run Postgres, ask yourself, do we have any alerting that detects this query suddenly got 50 times slower? Or this query changed plan? Or do we just wait for CPU graphs to screen? And separately, do we have a degraded mode strategy for the handful of flows that absolutely cannot be down? Auth, token validation, session refresh, payment, whatever it is for your product. Because the best incident is the one where users can still do the one thing they really need, even if the rest is on fire. Alright, story 3. This one's floating around as AI took down AWS, which is obviously the headline everybody wants. But the more useful way to look at it is this is a permission story. Reuters reported that AWS had a disruption tied to a cost management feature. And the reporting connected it to AWS's internal AWS tooling called Kiro. AWS responded by saying it was limited to a single service, not AWS broadly. It was limited to one region, and it was user error. Then AWS published their own statement basically saying the interruption was due to misconfigured access controls, not AI. They also say they added additional safeguards, including mandatory peer review for production access. You can believe whichever framing you want, but the operational takeaway is identical. If you have a tool that can take action, it is part of your control plane. Whether it's an agent, a bot, a pipeline, Terraform, a chatbot command, a script that runs at 2 a.m., or an internal self-service portal. The moment it can touch production, you need to treat it like production access. And the fastest way to get hurt here is letting convenience win over boundaries. So what does good boundaries look like in real teams? It looks like separation between read-only and write. It looks like separation between propose a plan and execute the plan. It looks like destructive actions requiring explicit approvals, not just it ran an automation, so it must be fine. It looks like a break glass path for emergencies that is auditable and annoying enough that nobody uses it casually. And it looks like logging actual tool actions, not just chat transcripts. Not the bot said it would delete things, I mean who called what API, with what role, against what resources, and what changed. Because in this new era, the hardest incidents will be the ones where everything moved fast, and nobody can confidently answer what actually happened. Monday take. If your org is messing with agents, or even just adding more automation, do one simple exercise. Pick one destructive action that exists in your environment, like deleting an environment, rotating a secret, revoking access, withdrawing a route, disabling a control. Now ask, can anything do this without a second human being involved? If yes, that's your risk. Not because AI is dangerous, but because any tool with power plus weak guardrails is dangerous. Quick platform note. AWS open sourced the EKS node monitoring agent. The big pitch is it monitors node-level system, storage, networking, and accelerator issues and publishes them as node conditions. And EKS can use those conditions to drive automatic node repair. If you've ever had a weird node that's half dead and you ended up SSHing in, tailing kubelet logs, checking disk pressure, and basically doing detective work while your workloads suffer, that's the exact pain that this is aimed at. I like this category of tooling because it's not another dashboard. It's turn node weirdness into a signal that the control plane can act on. If you are on EKS and you've had node flakiness incidents, it's worth a look. All right, time for the lightning round. I'm keeping this tight, 4 items and all high signal. First, Grafana. There's a high-severity advisory for cross-dashboard privilege escalation via permission management. The short version is, if someone has permission management rights on one dashboard, under certain conditions, they can read and modify permissions on other dashboards. If you run Grafana in a shared environment, this is one of those check your version and patch stories, not a someday story. Second, run C CVEs. AWS put out a bulletin for recently disclosed run-C issues that affect container runtimes when launching new containers. I'm not going to pretend everyone patches this instantly, because the reality is it depends on how you get your Node OS and runtime updates. But this is still a reminder to keep node rollouts and runtime patching as a normal muscle, not a panic button. Third, GitLab patch train. GitLab shipped patch releases that include important bug and security fixes, and they strongly recommend self-managed installs upgrade. If you self-host GitLab, you already know the deal. Don't let "we'll do it later" become "we got popped because we were busy." Fourth, Atlassian's February Security Bulletin. This is for the enterprise crowd still running data center products. They are calling out a pile of high severity and critical severity vulnerabilities fixed in recent product releases. Same story. If you run it, patch it. If you don't run it, thank your lucky stars and keep scrolling. All right, human closer. There's an ACMQ piece called SRE is anti-transactional, and it nails something that every platform team eventually runs into. Tickets don't scale. Manual work scales linearly. More requests means more humans. And that is how you turn a platform team into a help desk with pager fatigue. The SRE instinct is to build systems that do work for you. Not because you hate helping people, but because you want the systems to be reliable without requiring human glue for every small thing. And honestly, this week's stories are all versions of that same theme. Cloudflare tried to automate a workflow that used to be manual. The idea was right, but the guardrails weren't strong enough. Clerk got hit by a database behavior that didn't trip the usual failover assumptions. And they are evolving their system so the critical flows can survive partial failure. And AWS is in the middle of a bigger shift where tools are doing more, faster, and the only thing standing between helpful and incident is how you design boundaries and approvals. So if you are a platform engineer or an SRE listening to this, and you feel like you are buried in tickets, here's the move. Pick one repeated transactional pain this week, and don't solve it with another runbook. Solve it with an API, a self-service workflow, or automation with proper guardrails. Okay, time for a quick recap before we wrap. Cloudflare is a reminder that helper jobs are never just a cron. If automation can touch reachability, routing, DNS, certs, or anything shared, it needs production-grade guardrails and a rollback you can execute under stress. Clerk is the reminder that up but slow can be worse than down. If your alerting and failover only triggers on dead systems, you are going to miss the incidents that actually hurt. And the AWS Kiro story, no matter how you frame it, comes back to permissions. If a tool can execute changes, separate propose versus execute. Require approvals for destructive actions, and log the actual actions taken. Lightning round recap. Grafana's permission escalation risk, runc runtime CVEs, GitLab patch releases, and Atlassian's monthly security bulletin. Links for all of these are in the show notes. And the human takeaway. SRE is anti-transactional for a reason. Tickets don't scale. Build self-service and guardrails so humans stop being the interface for every little thing. All right. That's it for this week. If you want the full receipts and links, the full show notes are on shipitweekly.fm. And the curated weekly brief is on oncallbrief.com. If you got value out of this, follow or subscribe wherever you listen. And subscribe on YouTube if you are watching the video version. And if you've got an on-call buddy, send them this episode. I'm Brian for Ship It Weekly, and I'll see you next week.